Section 13, we're going to look at a variety of work with quadratic equations, including solving quadratic equations, using a discriminant and graphing quadratic equations. So we're going to start with a question with y equals x squared plus 8x minus 5. We're going to complete the square, sketch the curve, mark the turning point and the point at which we cross the y-axis, the y-intercept. So to complete the square, half the 8 down to a 4, that's going to be x plus 4 all squared. So this is if the question had asked to complete the square and sketch the curve. So x plus 4 all squared, half the 8 down to 4. 4 squared is 16, so we need to get rid of that 16 and still get rid of the 5, so that's minus 5. So that's x plus 4 all squared minus 21. Now since it's a positive x squared, then it's going to be a u-shaped parabola. We can then get the turning point, change the sign of that, don't change the sign of that. Turn point is minus 4 minus 21. To get the y-intercept, I would then think about x equals 0. So, go back to the equation. It can be the factorised version or the non-factorised version and sub in x equals 0. So if I was to throw x equals 0 into here, it would be 0 squared plus 8 lots of 0 minus 5, which is minus 5. In here it would be 0 plus 4. 4 squared is 16, 16 take away 21, still minus 5. So just let's sub that into one of them. So y equals 0 squared plus 8 lots of 0 minus 5, and that will give me minus 5. So I've got all the information I need now to draw the curve. It's a u-shaped parabola with a turning point at minus 4 minus 21, and it cuts the y-axis at minus 5. And that's that question completed. Question 2. We're going to factorise y equals x squared minus 2x minus 8. We're going to mark the turning point and find the roots as well. So essentially we're solving the equation to find the roots and then to find the turning point by factorisation. So I'm going to make the equation equal to 0. And two numbers that multiply together to give minus 8 add together to give minus 2. So that's going to be x minus 4x plus 2. So I've got x minus 4 equals 0, x plus 2 equals 0, x equals 4, and x equals minus 2. So I can then sketch what that looks like. It's a positive x squared, so it's going to be a u-shaped parabola. Root minus 2 and a root 4. Now the equation of the axis of symmetry, well, the axis of symmetry is a vertical line. Now remember that the equation of the axis of symmetry is just x equals a number, and the number is just where across the x-axis. So using a little bit of symmetry, halfway in between minus 2 and 4, well, from minus 2 to 4 is 6 units along. So from minus 2 to the axis of symmetry is 3 units along. So 3 units along from minus 2 is minus 1, 0, 1. If I was to work backwards from 4, I would get the same result. So work backwards from 4 by 3, and I would also get x equals 1. So the equation of the axis of symmetry is x equals 1. Okay, example 3. We've got a few examples that we're going to factorise and solve here. So I'm going to start with part A, and we're going to factorise and solve x squared minus 9 is equal to 0. Remember, the first rule of factorising is to look for the highest common factor. After that, you might be thinking about difference of two squares, or a trinomial approach if there's three terms. I look for a highest common factor and I can't find one with this example, so it's straight to a difference of two squares. So bracket with a plus, bracket with a minus, square root of x squared is x, and the square root of 9 is 3. So we'll get x plus 3 is equal to 0, x minus 3 is equal to 0, x equals minus 3, and x equals 3. And if I had been asked to sketch and mark the roots, those would have been the roots, and the axis of symmetry would have been easy to locate as well. Part B. Example B. I'm going to solve 5x squared minus 45 is equal to 0. Look for the highest common factor, and I find one, and that will be 5 bracket x squared minus 9. I can then do a difference of two squares with x squared minus 9, but remember there's a 5 in front. Square root of x squared is x, square root of 9 is 3. Bracket with a plus, bracket with a minus. I can then divide both sides by 5, and I'll get x plus 3 is equal to 0 and x minus 3 is equal to 0, which gives me a root at minus 3 and a root at 3. Okay, example C. I'm going to factorise and solve x squared plus 6x minus 18 is equal to 0. Look for the highest common factor, and I can't find one, so this time it's two numbers that multiply together to give minus 18 and add together to give 6. So if we ever think about that, two numbers that multiply together to give minus 18, add together to give 6. That's definitely, so it should be x squared plus 7x minus 18. So two numbers that multiply to give minus 18, add together to give 7, that's 9 and minus 2. 9 minus 2 is 7, 9 times minus 2 is minus 18. X plus 9 is equal to 0, x minus 2 is equal to 0. So I've got a root at minus 9 and a root at 2. Part D, we're going to factorise and solve 2x squared plus 5x minus 3 is equal to 0. Okay, so two numbers that multiply together to give 6 and add together to give 5 in the middle. That's going to be 6 and minus 1, so 2x squared plus 6x minus 1x minus 3 is equal to 0. It's then highest common factor, 2x bracket x plus 3 minus 1 bracket x plus 3 is equal to 0. Two brackets are then 2x minus 1 and x plus 3. 2x minus 1 is equal to 0 and x plus 3 is equal to 0. That's 2x equals 1 and x equals 1 over 2, or x equals minus 3.